Welcome to Toyota Time with Timmy the Toolman and Sean and special returning guest Fred.
Hey, how's it going?
So, Fred is letting us use his rig for our first ever AC system recharge. Now, there's a couple of reasons why you might be recharging your AC system. One is maybe it's just not working very well. It's not getting as cold as it used to be, so you're just a little bit low on refrigerant. Maybe you had a failure in some part of your AC system. Your compressor went bad. You got maybe in a front end accident. Maybe you hit a deer and your AC condenser was smashed and you have to replace the AC condenser for whatever reason. So there's a couple different things you would do. Recharging the partially filled system, or you're filling up a completely emptied system that you vacuumed first, and then you're going to recharge it with the full capacity of what your system holds. Now, this is going to be a little bit of a long video. All our videos are sort of long, but I want this video to be as complete as possible. So I'm going to describe how your AC system works on your vehicle. Then we're going to go out to Fred's truck and we're going to show you all the components that I talked about, how an AC system works, and we're going to show you what those components are on his actual truck. And then we're going to go through the whole charging system, how you would do it if you had an AC manifold gauge set, or if you were just going to use what the factory service manual shows how you can do it just by looking at the sight glass on the top of your receiver dryer. It's best to use an AC manifold gauge set, but if you didn't have one and you didn't want to buy one, the factory service manual does show a way for third gen Forerunners of how you can use the sight glass to tell you what the system is doing for you, whether it's underfilled, overfilled, or it's good to go. So I'm going to start by explaining how an AC system works, and then we'll go out to Fred's truck and I'll show you what all those components are on his truck. First, just to give you a little bit of history on refrigerants, the first refrigerant was called R12, and they found out is R12 is an ozone depleter. So they basically discontinued R12 and they brought in a new refrigerant called R134a. R134a is better than R12. It's not an ozone depleter, but what they found is R134a contributes to global warming. So just like R12, the EPA doesn't want you just letting this stuff out into the atmosphere. It's not good. So say if you were going to work on your system and it's not like you either have to replace a compressor or some component where you have to open the system up to the atmosphere. You're supposed to go to a place that can capture the whatever's left in the system. You have to bring it to a shop that can do that. They evacuate the system for you. Then you can open up your system, replace a hose, the compressor, the AC condenser, whatever you're replacing. Then you can properly charge it, but you're not supposed to let this stuff out in the atmosphere. It's against the law. You can let a little bit out when you're bleeding off lines and stuff, but you're not just supposed to just blatantly just discharge the stuff. So just a warning, you're not supposed to do that. So do it the right way. Now, if you had a failure, like the situation where a deer ran out in front of you and you smashed the front of your rig and now your AC condenser is smashed and it's open, well, you had no choice in that matter. The refrigerant went out in the atmosphere and it's not your fault. So you fix the system, you vacuum it out, and then you recharge it with the right amount of refrigerant. So just a little history of how the refrigerant has changed over the years and what the reasoning was for it. Okay, to start off, I want to explain to you how an AC system works. An AC system is a looped system, so I have to start the description somewhere. So where I'm going to start is right here, where the low pressure gas coming from the evaporator inside your passenger compartment sends the gas to the inlet on the AC compressor. Now, an AC compressor, it can't compress liquids, it only can compress gases. If you sent liquid onto the inlet side, you can mess up the AC pump. So the low pressure gas enters the inlet on the AC compressor. The compressor takes that gas and it compresses it. And the act of compression creates heat. There's different types of heat. There's heat from friction, there's other types of heat. So if you're familiar with scuba diving, or say if you're a firefighter and you fill air tanks, when you compress a gas, it creates heat. The compressor compresses that refrigerant, and it is now leaving the AC compressor as a high temperature gas. And so it funnels through the piping and it enters the AC condenser. And now the AC condenser's job is to cool that hot gas and turn it back into a liquid. Your engine fan is drawing air through the fins to cool the engine and the AC condenser. And also you have air pushing through the front grille of your vehicle, cooling that AC condenser. The AC condenser usually is in front of the radiator. It probably is on all vehicles, but I'm not 100% sure of that. But the AC condenser sits right against the radiator that cools your engine. So that cool air goes through the cooling fins, it drops the temperature of that hot gas, and it turns it back into a liquid. It leaves the AC condenser now as a high pressure liquid. Now in this part of the system, you might have a receiver dryer if you have an expansion valve. If you don't have an expansion valve, then you're not going to have a receiver dryer in this part of the system. So let's just pretend you have a system with a receiver dryer and an expansion valve. So the receiver dryer's purpose is to receive the liquid refrigerant, and it does a couple things. For one, since it's called a receiver, it receives the liquid refrigerant, and which has compressor oil in it also. It's a temporary holding place for refrigerant and AC compressor oil when the demand on the system is low. Say you're running the system at low speed and there's not a huge demand. So the excessive refrigerant that's not needed to cool your cab is kept in here. It also works as a dryer. So this thing has granules called desiccants. So if you're familiar with dehydrated meals, or if you get some type of packaging where they want to keep moisture out, there's those little desiccant packs. So moisture in an AC system is not good. It could freeze and cause problems. So the dryer portion of the receiver dryer takes any moisture out of the refrigerant and stores it there so it doesn't circulate through the system. Once the receiver dryer has done its job, then it sends the high pressure liquid refrigerant to the expansion valve. Now, if your system didn't have an expansion valve, then you'd have an orifice tube here. And they kind of do the same thing. They meter a certain amount of liquid refrigerant into the evaporator. This evaporator is usually on your passenger side behind the dashboard. If you have an expansion valve, it's metering refrigerant, liquid refrigerant into here. And then you have your blower fan blowing ambient air from your cabin of your vehicle over those tubes that the liquid refrigerant is running through. The R134a refrigerant is gonna boil at ambient temperature, at room temperature. So as the liquid refrigerant enters these tubes and the ambient temperature is being blown across the tubing, it's like a little radiator, it's going to rapidly boil and expand. And the process of boiling off and expanding has a cooling effect. And so when the fan blower blows air across the coils, it rapidly boils it off, expands, and it cools. And then you get the cold air going through your vents. And then once it gets through the evaporator, it returns back to the AC compressor, and the cycle repeats. Now, if you had an orifice tube here, instead of having a system with an expansion valve and a receiver dryer, you would have an accumulator somewhere in the line before it goes back to the AC compressor. The accumulator, what it does, if there's still liquid refrigerant, it didn't all boil off, the accumulator captures that liquid refrigerant, so you're not sending liquid refrigerant into the AC compressor and damaging the AC compressor. So to reiterate, with a system with an expansion valve, you'll have a receiver dryer. With a system with an orifice tube, you'll have an accumulator right in this area between the evaporator and the AC compressor. So I hope I did a good job of explaining. This is how any AC system is going to work in your car. And it's important to know how these things relate just for your own information and to help you troubleshoot your system when something goes wrong. So now on Fred's engine, I'm going to show you all those components I just got done talking about in the schematic, where they're all at on the 3.4 liter V6 engine that Toyota made, and walk you through the system on his truck. Now, depending on what vehicle you have, they're not all going to be in the same system, so you're just going to have to look to where your AC compressor is, start there, and then follow the lines to your AC condenser, to the receiver dryer, blah, blah, blah. So not every vehicle is going to be the same, but this is for the Toyota 3.4 liter V6. Just like we started on the schematic I showed earlier, this is the low pressure line coming from the evaporator in your passenger compartment. So it enters the pump, which is down here. That line, you can't really see it, goes into the AC compressor, which is right here. It compresses that gas into a high pressure gas, so it creates heat. So now it's going to leave the compressor right through this line, and this line goes up and it goes through the front grill area, and it's going to go towards the AC condenser. So this is now leaving the compressor as a high pressure gas. So we'll follow it around to over here. So the line has left the compressor and it goes into the top of the AC condenser, and it flows through all the cooling channels and it turns into a liquid. So now that the gas has turned back into a liquid refrigerant, it goes out of the bottom of the AC condenser and travels up this tube. And here it comes up, and here is your high pressure port that you would connect one of your manifold connectors, the high pressure side. So that's what that is. And it gives you, it dumbs it down. It puts an H on it so you know. Then it goes through the tubing again, and this is your receiver dryer. It enters there. This is the little sight glass that I mentioned earlier that you can tell how your system is properly charged by what you see in that sight glass. Then it leaves right here, and then it goes towards the firewall of the vehicle, and it goes through the expansion valve behind the dash. So here's that line that was leaving the receiver dryer, and then it continues right through here. There it is there, and it goes here. It is right here, and then it's going through the firewall. So once it goes behind there, it's going to go into an expansion valve that's going to meter the liquid refrigerant into the coils of the evaporator. Then the fan's going to blow air across it. It's going to boil off. It's going to rapidly cool, and you're going to get the cool air in your cabin. And then it's going to return back from the evaporator on this line. This is the low pressure line, and you see the cap. That's your low pressure connection if you're connecting up your manifold set. And then it returns back to the AC compressor. So this is all the components on your 3.4 liter V6 engine that they have on the 3rd gen 4Runners and the 1st gen Tacomas and even some Tundras. So that's an explanation of how this system operates on this vehicle. Now, if you're wondering, how do I know what kind of refrigerant my system takes and how much refrigerant? Well, on all vehicles, there's going to be a sticker just like this. So we're on the front of Fred's truck, right in front of the radiator on the body, they have a sticker, and it's showing that the system is filled with R134a refrigerant, and it's telling you the max amount. So it's telling you 1.54 pounds is the maximum. The minimum is 1.32 pounds. Now let's go over to one of the refrigerant canisters that I bought, and I'll show you how you can convert that so it makes more sense. So here's the conversion I was talking about. Because the label on the truck shows pounds, you got to convert pounds to grams. So the cans of refrigerant we're using say there's 340 grams of refrigerant in this can. And just so if you're wondering, well, is that the weight including the weight of the can? No, it's not. That's how much refrigerant. So I got this little scale here. So if I put the can of refrigerant on there, it's showing the whole thing weighing 438 grams. The can actually weighs about 100 grams. Using either a computer or a Smarty Pants phone, I just put in a value with a converter. 1.54 pounds equals 698 grams. So if the system was completely evacuated for whatever reason, from damage or a component that failed, and you evacuated the whole system, these two cans would pretty much almost fill the system. The two cans together is 680 grams. So you'd be really, really close. So I would say 2 cans of these would fill your system on a 3.4 liter V6 engine, no problem. So the first thing we're gonna do in Fred's truck is we're going to start it and then put a temperature instant read thermometer into one of his vents with the air conditioning on full blast, full cold. He's going to rev the engine at 1500 RPMs, and we're just going to see how well the system's running. And we have all the windows open right now. They say to have the doors open when you're doing the system, refilling it, but we're just gonna have the windows open because we're at a slant. I don't think the doors are gonna stay open. So all windows are open. Go ahead and start the truck. Okay, we're gonna turn the AC on. I have it on recirculate, fan blowing, full. Actually, it doesn't feel too bad. So let me turn this instant read thermometer on and we'll put it in one of the vents. Let's see how low this thing gets. Just try to hold it at 1500. So Fred's just holding the RPMs at 1500. Really not dropping, it's only getting to 75 degrees. So
I need it to be colder.
So Fred, so you're saying it's still getting a little bit cool, but not very cool, right?
Yeah, especially when it's like 90 outside, I start sweating.
Okay. All right, so that's what we're seeing right now is that with the probe all the way in there, I don't think that the windows open is having that much of an effect. The probe is way deep in there, so inside the vent, we're only getting to about 74 degrees. So, okay, let's shut it off and now recharge the system. So we're in the factory service manual in the air conditioning section of my 2000 manual. It's on AC3 page. And it says on vehicle inspection. So it gives you the steps. You're observing that sight glass at the top of the receiver dryer. They call it the liquid tube. You have the engine revved up to 1500 RPMs. You have the blower speed control on high, AC switch on, and you have the temperature control dial all the way in the cool position. It says fully open the doors, but like I said earlier, we're at a slant, so we're just going to open the windows. And it tells you different things. So if you have bubbles present in the sight glass, it's saying that you have an insufficient amount of refrigerant, and then it gives you the remedy. You check for a gas leak, and then you add refrigerant until the bubbles disappear. Say if you had no bubbles present in the sight glass, it can mean a few things. It can mean you have no refrigerant, you have sufficient level, or you have too much. So then it says refer to items 3 and 4. Item 3, it says there's no temperature difference between the compressor inlet and outlet. So that's basically you grab a hold of it with a bare hand and you feel the temperature of the pipe going in from the evaporator and leaving the compressor towards the AC condenser. You compare those two temperatures. And if there's no temperature difference between the two, then you might be empty or nearly empty. And the same thing, you check for leaks and then you add refrigerant until the bubbles disappear. If the temperature between the compressor and inlet and outlet is noticeably different, you either have the correct amount of refrigerant or you might have too much. So then it says refer to 5 and 6. Immediately after the air conditioning it is turned off, refrigerant in the sight glass stays clear. That means you have too much in the system. So it says to discharge the excess refrigerant, evacuate air, charge proper amount of purified refrigerant. The last one says when the air conditioning is turned off, refrigerant foams first and then stays clear. And that is telling you have the correct amount in there. So we're going to do this on Fred's truck by looking at the sight glass. We're going to see where his system is currently at with no AC manifold gauges just yet. So now we're going to check the system using the sight glass on the top of the receiver dryer to see what the system is doing currently, if it's too low, too high, or whatever. So we're just going to use that sight glass to measure the system right now. So Fred's going to get in the truck and start it, and then we're going to rev the engine from out here using a Torque Pro app that's taking information from a Bluetooth OBD2 reader hooked up to the OBD2 port in his truck.
Yeah.
Right. So Fred's going to start the vehicle. The windows are still open. He's going to put the AC on, the blower on high, and temperature control all the way to cold. And he's going to be on recirculate. So go ahead, start it up, Fred. Just on the top vent, it's fine. So I'm able to adjust the throttle right here by twisting the throttle. And now look over here. So the OBD2 reader is sending information to my Android phone via the Torque Pro app. So as I go up, I want to hold the RPMs at 1500 or somewhere close. And then I want to be looking at the sight glass and see what I see. So let's look at the sight glass now. So right now, I'm seeing a bunch of bubbles in there. Going back to the chart in the factory service manual, bubbles mean that the system is insufficiently filled. So that's what I'm seeing right now. It might be hard on the video, but I'm seeing, it looks like a lot of bubbles. So a better description is that it looks kind of foamy in there, so really small bubbles. Okay, so we know he's low on refrigerant based off of what we saw from that sight glass on the top of the receiver dryer. Now, there's two things that could be happening why you're low on refrigerant. One, you have a decent sized leak. Number two, just over time, it could leak out just a little bit minutely. The R134a molecule is supposedly really small, and it could make its way out of line connections. And it's not necessarily a leak, it's just because the molecule is so small. This truck has been in Fred's family since '96, and it's never received an AC recharge. So that tells me that this is just a normal process, that the R134a has slowly leaked out in minute amounts over time, and now it's finally to the point where there's insufficient refrigerant in the system to give them really cold air out of the vents. Now, if he said it went from being freezing cold one day to really hot the next day, that would lead me to believe that he has a leak in the system. So from what he has told me, it's most likely just a normal process of it slowly leaking out over time, and we're not going to be necessarily looking for a leak, but we're just going to recharge it, and hopefully he's going to be good to go for a long time to come. So now we're going to go through the steps of recharging the system. All right, so it's a good technique when you're working on your AC system. It'd be nice to have a little bit of dye in the system, circulating system. The reason why, if you ever develop a leak, you can use a kit. So you got the UV dye that you put into the system, and then you have these special glasses and ultraviolet flashlight to look for leaks. This one I bought on Amazon. It's made by Mastercool. So if you suspect a leak, you get dye into the system. I'm going to use this injection system that I bought, and I'll put a link to it in the description if you want to go this route. This is not the most affordable route. They also make refrigerant that already has dye in the system. So all you do is you put a little bit of the refrigerant that has the dye in it into your system to get some dye there so you can look for leaks. So with this system, it's going to be hard for you to see because it's very faint, but there's graduated marks. So if I tighten this thing down to where it's at the bottom line of I want to put a 1/4 ounce of dye into the system. That's usually about the right amount. So I'm going to screw this to where it's level with the 1/4 ounce line, and then I'm going to pour some in the top. I'm going to pour the 1/4 ounce in the top, and this thing actually has graduated marks too, so it's got a 1/4 ounce left. So I'm going to pour the whole thing in there. This stuff could be messy, so try not to get it all over the place on you, because it gets all over the place. Like I said, you screw the top on, and then you have to put a fitting on. So this is the quick connect fitting that's going to connect up to the low pressure port, and that's how I'm going to inject it into the system, via the low pressure port. So I screw this on, and now I got it set up. Now this hose could have a little air in there. You don't want to introduce air into your system. Air into the AC system is not good. So I have this coupling, this low pressure coupling that I'm going to connect up. And then I'm going to turn this dial into where I see some dye coming out of the bottom. That lets me know that it's fully pushed all the air out. Now it's just filled with dye, and then I'm good to go to introduce the dye into the system without introducing air. Once you're satisfied that no more air bubbles are coming out using this fitting, then you could connect it up to your low pressure port and inject it, knowing that you're just going to be introducing dye and not any air into the system. Okay, so now we're against the firewall on the passenger side of Fred's truck. I'm going to take the low pressure cap off, or try to. It's on there tight. That thing was on there tight, so I just used these spark plug wire pliers to get it loose. So now it's loose. So you unscrew the low pressure port cap, get it out of your way, and drop it. So this is just like any type of air compressor connection. You just slide it back and push down, or just push down and connect it to the low pressure port. Getting it at the right angle in here. We got an extra piece of machinery in here. So I had to get it at a weird axis. I had to go underneath the air tube to get it to where I can get the fitting on straight. So you just go in, push it on till it clicks. So what you do is you pull back the collar and snap it down. You'll hear it snap. Now it's on there. You turn this dial and it injects the dye into the system. Now many people out there, including myself, have successfully recharged their AC system with one of those little cheapo kits you get at O'Reilly's or Napa or AutoZone, and you connect it to your low pressure port. It's got this little gauge that tells you, based off the ambient temperature outside, what you fill it to. Now the bad thing about those is that all you're getting is the low pressure reading. You're not seeing what the pressure on the high side is, and to correctly fill a system you really want to know what the pressures are on both sides, low pressure and high pressure. Another thing is that how accurate do you think that little free gauge that comes with the refrigerant refill kit? I don't know. Maybe it's fairly accurate, maybe it's way the hell off. So like I said, many people successfully recharge their system. They didn't have to pay for a shop to recharge their AC, but then there's probably a lot of people that also try that system out and they end up overcharging their system, and then that causes problems with your system and might even ruin your compressor. So I'm going to show you the way to do it, the proper method with the AC manifold gauge set that mechanics use at a shop. And also mechanics use these really high-tech systems where they just hook up the system and this big fancy computer tells them everything and they don't even have to think. The computer does everything for them. But this is going to be the do-it-yourself method, or the way some auto shops do still do it without the fancy, super expensive machines. So let's go out to the truck and I'll show you the AC manifold gauge set. So let me describe the AC manifold gauge set. You have two sides. You got your low pressure side and your high pressure side. The low pressure gauge is a compound gauge, meaning it could measure positive pressure and vacuum, and the vacuum is measured in inches of mercury. It goes all the way down to 30 inches of mercury, and I'll explain the importance of that later when we're pulling a vacuum. And this is the high pressure side, and you'll see the values are different. We're going to be looking on the outside of the dial in the PSI range. So the high pressure goes from 0 to 500. The low pressure goes from 30 inches of mercury all the way to 120 psi. And then these are your control knobs. So I'll explain what the control knobs do later once we get the hoses connected. So let me show you the hoses. So everything's color coordinated for you to make it easy. So you have your blue line, which matches up with the blue knob over on the manifold gauge. And then you have your yellow line, which is the service line that you use to vacuum the system and also to add refrigerant to the system. So that's the service line. And then you have the red line, which is your high pressure line, and that's telling you what the pressure is doing on your high pressure side of the system. You got your three lines that we're now going to connect up to the manifold, and I'll show you how you do that. So I'm going to hook up the high pressure one. So it just twists on, simple fitting. And hand tight. You don't have to really, they have O-rings, so you don't have to crank it on with the tool. Just finger tight, that's good enough. Now I'll hook up the service line. And then I'll finally hook up the low pressure line. Alright, so now those are all connected. So let me describe what these knobs actually do. If I connect this low pressure connector to the low pressure port and this high pressure connector to the high pressure port, I'm immediately gonna get a reading on these gauges because the pressure in the system goes directly through the manifold and into these gauges, okay? So you don't have to have these open to get a reading. That's not what these do. What these knobs do is it isolates the high pressure from this center portion where the service port goes, and it isolates the low pressure side also. So when you open these valves, it lets the pressure go towards this middle section of the manifold, which hooks up to the service line. So when you're filling refrigerant from the low pressure side, the refrigerant is coming up from your canister through here. You open up this valve and it's going to go through here, down the line into your low pressure side of your AC system. So that's an explanation of what these knobs actually do. It just isolates the refrigerant from this center portion. So there's two types of connectors. There's the type of connector that you saw like on my dye injector system, that you just snap it on and it immediately pushes down on the Schrader valve. There's basically the same type of valves that you'd see on a bicycle tire inside the tubings for the high pressure and low pressure ports. So there's the type that you just snap it in place and it automatically is accessing the system. With this type, there's an actual little nipple here that when I hook this up and this thing's backed off all the way, I'm not into the system yet. I have to screw this knob down to where this pin will now push pressure on the Schrader valve and then access the system, and then I could see what the pressure is. Same thing on the high pressure side. They're built the same way. So this type of one, you pull back the coupling, you snap it on, and then not until you actually dial this down to depress the Schrader valve, you're actually seeing what the system is doing. So since Fred's system is partially charged, not fully charged, we don't want to introduce any air into the system. Now, what some AC techs say is that when you connect up the lines, you want to purge the air out of the system. So to purge the air out of the system, you open this up a little bit and you get it to where refrigerant starts coming out, and then you close it off. That means that you pushed any air out of here and now you got straight refrigerant coming out. And then you do the same with the high pressure side. Or what you can do, this system has a little Schrader valve here. What you can do is keep this tight, open up this valve to where it accesses the middle of the manifold, and then depress this to where refrigerant starts coming out. And so that's how you can bleed the line. But another way to do it is I'm going to pull a vacuum on this system, and you're going to see that the lines are holding a vacuum by what's indicated by the gauge. Once I disconnect it from the vacuum pump, you're going to see it holding a vacuum. That means that I've evacuated the whole manifold and the lines of all the air out of the system. So when I connect it to the low pressure and high pressure port, I won't end up pushing air into the system because it's vacuumed out. Okay, so here's my rotary vacuum pump. You connect the service line to it, and there's two different fittings. I think the top one is like for an old R12 system, and then this one right here is for the R134. So again, I put it finger tight, and then right now, neither one of these lines is hooked up to the AC system right now. They're both just hanging there free. And when you look up here, the vacuum pump's going to start sucking air out of the system. And to also suck air out of the low pressure and high pressure lines, I'm going to open these up. So now it's going to be sucking from both sides. It's going to start sucking through here, suck it out of the manifold, and it's going to start sucking it out of both lines, to where I basically draw a vacuum on the manifold itself and all the lines. So I'm going to start the pump. And now let's look at the gauges. You could see that it's pulling a vacuum right now Now with my actual manifold set, what I've noticed that it doesn't pull to a full 30 inches of mercury. I've also read that a system, you can't really get a perfect 30 inches of mercury, but I've seen it online that they do, and I don't know if it's the fact that my pump is just not good enough to pull 30 inches of mercury, or maybe this gauge set is just a little off and it won't show a full 30. If you look over here, since this isn't a compound gauge, you can see that it's gone down a little bit, showing that it's pulled a vacuum on it. It's like the needle's pegged out below the zero, showing that it's pulled a vacuum on the high pressure, and then the inches of mercury showing that it's pulling a vacuum on the low pressure side also, with these valves open. So the vacuum pump's been running for a while. It's not getting any lower. 28 inches of mercury, somewhere around there, 26. Like I said, I don't know if this gauge is that accurate. So with the pump still running, I'm going to close off these valves. Now I've isolated the high pressure and low pressure lines from the manifold. It's not going to go through here anymore. Now I'm going to turn off the pump. Now if I disconnect this line here, there's air through this line, but you can see that these two are still holding that vacuum. This high pressure side is maxed out, needles buried, and then this one's holding the inches of mercury that we vacuumed down to. So I know that these lines have now been evacuated of air. Okay, so now I'm going to connect the low pressure side to the port. I have this dial backed off all the way, and I'm going to push down and hook it up to the low pressure side. You pull back the sleeve, you push down, and then pull up to see that it's on there tight, that you got a good connection. Now if we go back to the gauges, you could see that I'm not reading anything yet because I haven't depressed that Schrader valve inside the low pressure side yet, because I haven't turned the dial on the end of the line. So now let's hook up the high pressure side. So again, the high pressure side is right here in front of the grill. I'm going to pull back this sleeve, push down, and then pull up. And then again, you can go back up to the gauge and you can see that there hasn't been any change yet. So now I'm going to turn this down, and now you can look back up at the gauge and you can see what the static pressure is in the system right now. And then I'm going to do the same with the low pressure side. I'm going to turn down the dial, and the pressure is going to go up. And it looks like, you know, one might be a lot different than the other, but they're different levels. So right now, his system, I had him start it briefly. Usually as the AC system is sitting a long time, these two pressures will equalize because the system is static. So this is what we're showing as a static pressure. If the truck was sitting for longer, the low pressure and high pressure side will equalize. But since I just had him running the AC briefly, it's a little bit of a differentiation. The high pressure is a little above 100 and the low pressure is showing as 80. So the static pressure can tell you that you have some refrigerant in the system. How much refrigerant you have in the system, it's not a dead giveaway. But what this will tell me is that the AC system is able to kick on because there's a low pressure switch that protects the compressor from damage. You need a certain amount of refrigerant circulating through the system to move the compressor oil through the system to where you properly lubricate the AC compressor. The low pressure safety switch will most likely cut off, from what I've read, at about 20 psi, and then it won't kick back on till the system reaches 45 psi. So say if we were right around 45 psi and the system was low, the compressor might kick on the kickoff, kick on the kickoff. They call it short cycling, letting you know that there's not enough pressure in the system to keep that low pressure safety switch from engaging. So this is basically telling me that his AC system has enough pressure to operate, but maybe not enough pressure to necessarily cool the system, because we don't know how much refrigerant is in the system based off of static pressures. So now we're going to turn the engine on and the AC on, and then we're going to see what the system's doing on the low pressure and the high pressure side. With the engine running at 1500 RPMs, AC on full blast and full cold, and the windows open. You got the AC on full? So the AC system is on full. I got it at right around 1500 RPMs. And let's see what the gauges show. So right now, his system's low. Based off of the ambient temperature outside today in San Jose, California, it's in the high 80s right now. So he should be closer to 30 PSI. And I'll go to the factory service manual now, and I'll show you what the value should be at this temperature today. So now we're back to the factory service manual in the air conditioning section again, and it's talking about the testing situation with the manifold gauges and what you're looking for in the pressure wise. So test conditions, it's saying the ambient temperature between 86 and 95 degrees. We're currently at 88 degrees in San Jose. When we ran the engine at 15 RPMs with the control switch for the AC on high and fully cool, we were reading 8 PSI on the low pressure side and 150 on the high pressure side. Now this book shows it in two different values, in megapascals and kilograms of force per square centimeter. So what I did is I used my computer for a converter from megapascals to PSI. So these values in megapascals equate to 21.7 PSI to 36.2 PSI. And then on the high side, a range of 198.7 PSI to 227.7 PSI. So again, his values were 8 on the low pressure and 150 on the high pressure. That means he is low on refrigerant, and it seems like all we'll have to do is top off his system to where we get into this range, and then we'll probably be good to go. Now what is this? This is a can tap. What this little doohickey does is you screw it on to the top of here, and anywhere other than the People's Republic of California, you screw it on with this thing backed off all the way, and then you screw this little thing in, and it's got a spike and it pierces the can. And then once you've done that, the way to start getting refrigerant into the system is you back it off, taking the spike out of the hole, and then the refrigerant goes out of this valve into the yellow supply line, into the manifold gauge, into the low pressure or high pressure side, and that's how you're filling refrigerant. If you pierce this can, what California worries about is that if you don't use all the refrigerant and you pierce the can and you take that can tap off, now you're just going to expel all this excessive refrigerant into the atmosphere, and they don't like that. So they have this adapter, and this adapter you could buy at the auto parts store. It works okay, but it's not the greatest. So you screw this on first. So since we're in California, we're going to screw this on first. Now this part is a little counterintuitive. Like I said, anywhere else in California, you would start with this piercing spike all the way retracted. But with this adapter system, what I learned is if you do it with the retracted, you start screwing it into here, you start spewing refrigerant out at yourself. You know, so that's not good. So for safety wise, wear gloves, rubber gloves, whatever, just protect, because this gets really cold. It gets really cold because at an ambient temperature, it immediately boils, just like it's doing in your evaporator. So to protect your hands, in case something squeaks out at you, you just wear some gloves. So with the spike all the way out, with this type of system for California, I'm going to screw it on the top. For safety reasons, just if you're not sure, if you're paranoid, just have this pointed away from your face. So now, this thing's tight, just hand tight. Now this thing's ready to go. to be connected to the yellow service line that leads to the manifold. So I'm taking my yellow line and I'm connecting it. Hand tight. Now, this yellow line is going to have air in it. It's not vacuumed down anymore. So you can do a couple different things. You can open up the can first and then keep these closed for right now, and you just crack this until you get liquid refrigerant coming out, and then you close it. So you're going to escape a little bit to the atmosphere. But the other way is there's a Schrader valve here. So I'm going to back off this valve. Now refrigerant is going through this line towards the manifold. So I'm going to use the Schrader valve on the manifold to bleed this yellow line of air. So I've got my face to the side. I'm going to depress this. When air stops coming out and it's pure refrigerant, I'm going to stop. So I got the can upside down that I'm more charging it as a liquid, and then I want to see a spray of liquid coming out of there. I just don't want air coming out or gas coming out. That's good right there. So you saw that spray? That means I've evacuated all the air out of the system. Now we're good to start charging. All right, so you just watched me prep this service line to charge the AC system on Fred's truck. I used the refrigerant here to flood this line with refrigerant and push all the atmospheric air out of here to where liquid refrigerant was coming out of the Schrader valve, and now this is ready to charge the AC system on his truck. But what I wanted to show you is that there is actually another way to prep this line. Remember that I first drew down a vacuum on the manifold set and the low pressure and high pressure sides, and then I disconnected this. Well, newer manifold sets have a valve on one end of the fitting, and that valve will enable you to pull and hold a vacuum on the service line, so you don't actually have to flood this service line with refrigerant to get rid of the atmospheric air. You can draw a vacuum on the whole system, the service line, the low pressure line, the high pressure line, and the manifold all at one time, disconnect it from the vacuum pump, and it will hold the vacuum. So this way you don't have to go through the step that I just showed of flooding this service line with refrigerant and letting a little bit out into the atmosphere. So the more clean method and better for the environment is to actually pull a vacuum that will hold. Now, the reason why I showed you the first method of flooding this line is that older manifold gauge sets might not have the available valve with the service line to where it will not hold a vacuum, and then you're forced to flood this line with refrigerant so you get the atmospheric air out of here, so you're not pushing it into your AC system, which isn't good. So I wanted to first show you the way to flood the line, and now I wanted to show you the other method that I like better, which is pulling and holding a vacuum if you do have a newer manifold gauge set that has a service line with the valve that will hold a vacuum. And I'll show you what the ends of the fittings on this service line look like, so you know which one is the correct one to hook up to the vacuum pump and which one is the correct one to hook up to the manifold gauge set. So here's the two different sides. You have this more open side where it's just a straight tube that goes down, and then you have this other side that has an actual type of fitting. And to be able to draw and hold a vacuum on this service line, you actually have to hook up this one with the fitting onto the vacuum pump, and the one with the open end goes to the manifold set. So now I'm going to hook those to the vacuum pump and the manifold set. I'm going to draw a vacuum, and you'll see once I disconnect this connection from the vacuum pump, the system will still be holding a vacuum. All right. So I'm going to connect up the side with the valve to the vacuum pump, and I'm going to connect up the one with the open end to the manifold set. And again, these just have to be finger tight. Now I'm going to start the vacuum pump. I'm going to open these up. So now that the vacuum pump is going to be pulling a vacuum through this line, through the manifold set, down these individual low and high pressure sides. you'll see that once I disconnect this yellow service line from the vacuum pump, with these valves still open, that everything's going to be holding a vacuum, showing that there's a vacuum still in the service line, there's a vacuum being held in the high pressure side, and there's a vacuum being held in the low pressure side. Okay, I'm going to switch off the pump. Now we're going to be looking at these gauges. I'm going to disconnect this valve. So now this is disconnected, but you'll see that these valves are open. They're all the way open. So it's allowing a pathway from this service line through the manifold to both of these lines. So the fact that this is now disconnected, it's not connected to the pump, you could see that it's holding a vacuum through this line and through these. Now, to show you that this thing is actually holding a vacuum, as soon as I unscrew this, this is going to allow ambient air from the atmosphere to enter the manifold gauge set, and these things are going to lose their vacuum, the high pressure and low pressure side. So watch this. You saw the gauges drop? That means that there's no longer a vacuum on the system. This method, I believe, is the preferred method, because this way you don't have to bleed off this yellow service line with refrigerant to push the air out of the line, so you don't end up introducing air into your AC system, which isn't good, like I explained earlier. I like this method better if you have a newer manifold gauge set that you bought from wherever, Harbor Freight or Robinair, wherever. They'll usually have that available valve on one side that you connect up to the vacuum pump that will allow this to hold a vacuum once you disconnect it. And this way you can just start by charging your system and not worry about pushing air through this line and into your AC system. Now there's one more thing that I wanted to explain to you before we get started on recharging Fred's AC system on his 3rd Gen 4Runner. What you're accomplishing with either vacuuming down the manifold gauge set by itself to prep it to top off a system, or you're vacuuming down the manifold gauge set while it's connected to the vehicle, and you're vacuuming down the whole AC system on the vehicle to prep it for refrigerant. What you're accomplishing when you vacuum down the system is you're removing the atmospheric air from the system, and then you're also getting rid of moisture out of the system. Now, some people think that when you're operating that vacuum pump hooked up to your AC system, you're actually pulling the moisture out, and that's not correct. What you're doing is you're lowering the atmospheric pressure so low that you're lowering the boiling temperature of water. And when you draw a vacuum on a system and you get it to a low enough level of inches of mercury, water is going to boil off at ambient temperatures. So that's what you're actually doing. You're not sucking the moisture out, you're actually lowering atmospheric pressure. Another way to describe this is, for those of you that have gone to higher elevations, as you go up in elevation above sea level, at sea level, atmospheric pressure is 14.7 psi. As you go up higher, atmospheric pressure lowers. And when the atmospheric pressure lowers, water boils off at lower temperatures. So if you've ever tried to cook pasta or boil potatoes, whatever you're cooking in boiling water, you've noticed at a higher elevation, it takes longer to cook that food because the water is boiling at a lower temperature now. So on the extreme side of that, when you draw a vacuum, basically removing the atmosphere from the AC system, you're allowing that water to boil off at a pretty low temperature. So now I'm going to go to my computer and I'm going to show you a chart showing at what level of inches of mercury you will get water to boil off at certain temperatures. So here we are in front of my computer. This is saying the boiling point of water at various vacuum levels. You have the temperature in Fahrenheit right here, temperature in Celsius, the microns that the vacuum pump will pull down to, the inches of mercury that it will pull down to, and then this is the pressure at pounds per square inch actual. So look at this value, 14.7. Remember I said atmospheric pressure at sea level is 14.7. You have 0 inches of vacuum. The microns is 800,000. Temperature at which the water will boil will be 100 degrees Celsius or what most of us know in the Western world, 212 degrees Fahrenheit. As you start pulling a vacuum, and remember I showed that my vacuum pump could pull to about 26. Now, whether or not that's an accurate number, my gauge set isn't accurate, or maybe my vacuum pump just doesn't pull enough of any more than 26. If you scroll over here, it shows that water would boil off at 50 degrees Celsius or 122 degrees Fahrenheit. But if you were able to pull 28 or close to 29, then water would boil off at 80 degrees. Today in San Jose, we're really close to this temperature. We're right about 88 degrees. So if I was able to pull 28.67 inches of mercury, I would get any moisture in Fred's AC system, if we were pulling a full vacuum, to boil off in the system, because we've lowered the atmospheric pressure so low that water would boil off at 86 degrees Fahrenheit. So if you had to open up your AC system because you had some type of damage or you had a broken component, once you got everything airtight again, you vacuum down the system with a vacuum pump. You run it for anywhere from like 30 minutes to an hour, whatever makes you feel good, but usually at least about 30 minutes to where you pulled a good vacuum. And then a lot of people will disconnect it from the vacuum pump and then watch the system for a while to see if there's any leaks. And then once they're satisfied that there's not any leaks, then they'll go through the recharge procedure of filling the system with the recommended weight of refrigerant based off of the label you saw underneath the hood of your vehicle. So I hope I did a good enough job of explaining what you're actually accomplishing with vacuuming down the system, so you understand what you're actually doing for your AC system before recharging it with refrigerant. Now, this is really important. I hope you haven't skipped through the video and missed this. You technically can fill on the high pressure side, but what there is to note is when you're filling from the high pressure side, which the high pressure side you can fill with liquid. So when you have the can in this orientation, there's vapor above liquid, and you'll be charging as a gas. If I turn this thing over, now I'm charging in a liquid state. So you can charge on the high side. You can get it in a lot quicker via the liquid method, but the very important thing to note is that the truck or vehicle has to be off. You can't have the AC running, because if you're filling from the high side, the high pressure coming from the high side of the AC will come back through this line and blow this canister up. So what most people say, it's just safer to charge from the low pressure side, but I wanted this video to be complete. So if you wanted to add refrigerant into the system quicker with the engine off, you can access the high pressure side via the manifold and turn the canister over and fill it quicker, and then you could top it off, finish off topping it off via a gas state through the low pressure side. What we're going to do today on Fred's truck is we're not going to mess around charging from the high pressure side, because this is more of a situation where you've fixed the system has been totally evacuated, and you're going to be charging it up based off of weight like I showed you earlier, and you just want to get the liquid refrigerant into the system quicker than doing it via the gas method on the low pressure side. So now what I'm going to have Fred do is he's going to start the engine again. Windows are open. He's going to have the AC blower fan on high, the cold setting all the way cold, and then we're going to monitor the RPMs at 1500 RPMs, and then we're going to be watching our manifold gauge to see the pressures and know kind of where to stop. So Fred's just going to be monitoring via the Torque Pro app. He's going to try to keep the RPMs at about 1500. So right now, the refrigerant is filled up to here into the manifold. The high side and low side are closed off. I'm not going to mess with the high side. Remember, if we open the high side, that's going to allow the pressure from the high side to come through here and explode that canister. Very dangerous. So I'm going to open up the low side, and that's how I'm going to feed refrigerant. The refrigerant's going to go up through here, through this valve, down through the low pressure line, and into the low pressure side of the system over here. Another technique that they show is that I'm going to be, when I'm filling it with refrigerant, I'm going to be rotating it from the 12 o'clock to the 3 o'clock position like this. This increases the speed of you're adding refrigerant, so you're kind of going from like a gas to a slight gas liquid back and forth. This is acceptable, what you'll see AC technicians doing. So I'm going to open this up. And now I'm going to start rotating my can. And this can take a while. We want to see the pressure come up. So remember, what I'm doing is I'm looking at these numbers and I'm thinking, I'm going to try to bring the system up between these values. Right now it's creeping up to about 30. And I'm going to want to see the high pressure side go up somewhere between 200 and 227. When you're going from 12 to 3, you can shake it. It helps get the refrigerant out. You can see our pressures have come up now. So he has it close to 1500 RPMs. After almost putting a whole container of this, we're closer now to the values we're looking for. We're closer to 30 psi. We're at about 26, and then we're at about 215 on the high side. In case you were wondering, the AC system is on this whole time. We've got the AC on full blast, windows open, RPMs at 1500. So now that we have the low pressure and the high pressure in the range that the factory service manual states, if you don't have a factory service manual, you could also get just like a basic chart. But what I found with the charts is that there's big discrepancies. At one temperature, one chart will show certain value for the low and high pressure side. You go check out another chart online and they'll get totally different values with pretty wide range of numbers. So I'm using the factory service manual, what it said in the temperature range we're currently at in San Jose, California. So now I'm going to have Fred turn off the truck. The AC will go off too. I've turned off the can tap before he actually turned off the engine. Based off of the low pressure and the high pressure values, we think that we're right in the ballpark of it being properly recharged. We've got this low pressure side, we're going to turn it off. And then now you'll see that there's still a lot of stored pressure in there, okay? So we want to somehow get that pressure out of there. So turn this knob to where it's not pushing on the Schrader valve. And now I could safely take this off. You just hear a little wisp of air. So now this is isolated. See that this still is holding pressure. This is off the car, but this still is showing like 175 psi. This is still connected to the low pressure side. So what I've learned is that because of that pressure, there's a lot of liquid refrigerant and there's a lot of AC compressor oil in this line, and we don't want to lose that. So we want to get it back in the system. I'm going to keep this closed for right now. I'm going to open this up. Now, since this isn't connected to the engine anymore, I could safely open this up. So I'm going to create a pathway from the high pressure side through the manifold into the low pressure side, and hopefully these pressures equalize. So I'm taking a little bit of the excessive pressure on the high pressure side, and it's going to dump into the low pressure side. Before you try to equalize the pressure on the high pressure and low pressure sides, turn your can tap all the way off, clockwise to where the pin is sticking all the way out and it's locked off. That means this thing is closed. Unscrew the can tap from the can. You might hear a little wisp of refrigerant, that's it. And then set your can aside and keep the can tap on the end of the service line with this can tap turned off. Now the reason why you're keeping the can tap attached to the service line with the can tap turned off and the service line still connected to the manifold gauge set is that when you're ready to equalize the high and low pressure sides, if you open this valve up and there's nothing connected to the service line port, all that pressure is going to escape out here. So you don't want to give the pressure a path out the service line, and that's why you have it capped off on this end. You want the pressure from the high side to go through the manifold down the low pressure line, and this would be connected to your low pressure port. So you're equalizing the pressure between the high and low pressure sides. And the reason why you disconnect the can from the can tap is that if you messed up and didn't have this closed off all the way, you don't want the residual pressure from the high pressure line going through the manifold, through the service line, through the can tap into this can and possibly exploding the can. I don't know if residual pressure in the high side could potentially rupture the can, but I don't want to take a chance and give you bad information. So the safer bet is to disconnect the can from the end of the can tap, have this turned off, and then now you're ready to equalize the pressure, to relieve some of the pressure out of this high pressure line. So when you disconnect and you bleed off the system, that you're not losing a bunch of refrigerant out of the high pressure side, which I've seen before firsthand. So now you see they're equalizing. So now the high pressure dropped about 75 and the low pressure is now at about 68. So I got some of the excess pressure in here. So now we see the two sides have equalized, that they're both right around, well, 65, and this one's right about 60 something or 70. We've reduced the pressure. What an AC tech that I read on a couple different sites, they say what they do to reduce it even more is they keep the low pressure side connected. They're still running the AC. They disconnect the high pressure side. This is open, and then they crack this and they let the low pressure side suck what's left in the high pressure side into the low pressure. The one thing that I don't know for sure, and that I'm worried, is that they say that you're not supposed to put liquid refrigerant on the low pressure side because it's hard on the pump. So I don't want to run that risk with Fred's system, so I'm just going to leave the residual pressure in the lines for now. I'm not going to worry about it getting the rest of that pressure out. So there is still a little bit of refrigerant in the lines, but not as much as before I equalize the two sides. So now I'm going to disconnect the low pressure side. So I'm going to back off the knob and then disconnect. These, remember, were both at about 70 psi, these dials. So what I did individually is I opened up this one, and this is going to send whatever's left in the blue line through the service line, and it was just a tiny little puff of refrigerant, nothing at all, like actually less than when we did to bleed the service line of air when we started the refilling process. So just a little puff out of both sides. So again, what you do is you have this off your canister, you open this up, and it's going to go from the line through the manifold, out the yellow line, and out the end. You close this one off, you open this one up, same thing. It's going to go through the red line, through the manifold, out the service line, and out the end. And then you got your gauges back at 0 again. So that's how you evacuate it. Okay, so when you're done with the system, good to remember to put your caps back on. It keeps debris out of there, especially if you go four-wheeling. You want to keep the threads clean in there, and the fittings, you know, free of any dirt and crap. So put your caps back on. So put your high pressure cap back on, And then Fred's over there, he's putting the low pressure cap back on. So don't forget that. Okay, so now we're gonna see the result we did by recharging the system, using the manifold gauge to see the low pressure and high pressure side. We're gonna go inside the vehicle, we're gonna put the instant read thermometer into one of the air conditioning vents, and then we're gonna see what temperature we got now. Okay, we have the engine on. We have the AC on recirculate, the fan on full blast, fully cold. I'm gonna stick it into the vent. And now let's see the temperature. Remember, what was the lowest temperature we got to last? We got to 75 last time. He's revving at the 1500 RPMs. Now this is just sitting right here in my driveway still. So we got down pretty far. It's going down to 53 degrees. And it's a hot day. It's about 90 degrees right now outside. He's cooling pretty darn good. So now what we're gonna do is we're gonna see via the sight glass method that the factory service manual talks about, and we're gonna see what the sight glass looks like now that we got done adding some refrigerant to the system. So the engine's running, and Fred's gonna turn the AC on. So go ahead, turn it on, Fred. So what I just saw is that it was a little bit bubbly at first, it was foamy, and now it's completely clear. And that's what we want. The factory service manual said that if it's clear, it has sufficient refrigerant. Now when he turns it off, it should foam and then go clear. So go ahead and turn it off. So it foamed and it went clear. So we're good, we're not over full. So I think we did a good job.
Hello.
We're driving, and now we want to kind of just see how good this thing is doing. Yeah, so this thing is doing pretty good. Sorry for the bouncy picture, but it's down to 50 degrees driving down the road. So from his 75 degrees sitting in front of my house, Fred says he's happy. You happy, Fred?
Yeah, stoked.
Okay.
So much better.
So I think we did it right. Amazing. All right, so as a final step to this whole drawn out process of me blah, 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 a whole lot, and trying my best to explain this, being a novice AC person myself, we took it for a test drive, and we went on the freeway briefly, and we were able to get the temperature down to 42 degrees. So I think that's pretty good. Fred's happy. I think it worked out pretty good. So AC systems are a little bit complicated, and I wanted to hopefully share with you how a system works, what it looks like on a third gen 4Runner, or if you have a first gen Tacoma, it's the same thing, 3.4 liter V6. I hope I did a good enough job to explain how an AC system works, what it looks like on a 3.4 liter V6 Toyota engine, and then how to safely recharge it using an AC manifold gauge set. Now, if you aren't fully confident that you can handle this, you're probably just better off taking it to an AC shop that recharges AC. They'll probably charge you $100 and let them do it. But if you're like me and you like the do-it-yourself stuff of automobile mechanics, then go ahead and invest in a manifold gauge set. Maybe get a dye injector if you want, or maybe just use some refrigerant that has dye if you ever want to check for a leak. And then use my tutorial as a reference. Read up on it. There's tons of information on the internet about AC systems, how they work. There's other really good YouTube channels that I found that I use to help me learn. One of them is Engineering Explained. That guy does an awesome job. He has over 1 million subscribers, so he's doing something right. And then another one was Ratchets and Wrenches. That guy is really good at explaining things. He has a good video of how AC systems work. So if I somehow didn't do it clear enough for you, just do more research on the internet and read up on it. So I finally felt confident enough to be able to explain it to anybody viewing my channel or coming across it on a Google search. So when it comes to auto mechanic do-it-yourself stuff, AC systems are a little bit more on the technical side. There's a lot to know and be concerned about. You know, especially about the high pressure side and not potentially blowing up a canister. You know, play it safe and just fill your system via the low pressure side. I won't even mess with the high pressure side. So with all that said, I would only tackle this if you feel confident that you can do this safely. If you're not confident, like I said, take it to a shop and just let them do it. Or maybe you have a friend that has the AC manifold gauge set, has some experience with it, and let them help you. But if you're unclear, either from watching my video or other videos or reading up, if you're not really clear how to mess with your AC system, then I would say don't mess with it. Just let somebody that knows what they're doing do it for you. Where I bought my AC manifold gauge set, I went on Amazon. I've heard that the Harbor Freight setup is pretty good. Harbor Freight sells an AC manifold gauge set that's decent. I saw mixed reviews on the Harbor Freight set, so I decided to buy one from Robinair. And so in the video description, I'll put links to the Robinair AC manifold gauge set that I bought via Amazon. I'll put a link to that dye injector and anything else that I bought for AC systems. You can get those little adapters at any auto parts store that you buy with the refrigerant. And then these refrigerant canisters, they charge you a core charge. So save your receipt when you use up the refrigerant. They charge you like a $10 core charge. So once you've evacuated all this, then bring it back to the automotive store that you bought it from, and they'll give you your $10 back. So remember that they'll charge you a $10 core charge, and you'll get your money back when you return this canister. We thank you for watching Toyota Time with Timmy the Toolman and Sean. We will be back with more videos. Thanks for watching. Thanks for subscribing. Take care. Bye-bye. Why are you moving shit on me? Why are you moving shit on me, bro?